Okay, we're continuing our review of basic Algebra 2 concepts. Today's day 3. It's section R.4, which is factoring. Everybody loves factoring. It's going to be fun. We're going to start with greatest common factor. And when you have a polynomial that we're factoring, first you look for the GCF, or the greatest common factor, of the coefficient. Remember, coefficients are the numbers in front of the variables. And what you want to remember is you want the largest number that goes into or divides into each coefficient. So on this first one, I look at 6 and 9 are my two coefficients, and I think about what the factors of 6 and 9 are, and what's the biggest number that can go into both 6 and 9. Well, my factors of 6 are 1 and 6, and 2 and 3. I like to write them as factor pairs. Those are all the factors that go into 6. And for 9, all the factors that go into 9 are 1 and 9 and 3, because 3 times 3. So the biggest number that is a factor of both of them, or that goes into both of them, is 3. So I'm going to factor out of 3. For the coefficients, find your greatest common factor of your not your coefficients, your variables. You look for whatever variable is the same. So in this case, it's an x, and you're going to use the smallest exponent to factor it out. So here I do have a common variable, and that's x, and the smallest exponent I have is x to the first. So that's the one that I'm factoring out. To figure out what's left, I put the parentheses, and the first term of the parentheses is whatever I can multiply times this factor to get 6x squared. Start with the coefficients. What times 3 gives me 6? Well, that would be 2. On the variables, remember when we're multiplying variables, we're adding exponents. So what times x to the first will give me x to the second? Well, I'd have to have another x to the first to get x to the second. And then this is going to be what times 3 gives me negative 9? Well, that would be minus 3. And what times x to the first gives me x to the first? Well, I have all I need, so I'm not going to have any more x's. So that's your final answer. So it's 3x times 2x minus 3. The greatest common factor is the 3x. The factored polynomial is going to look like that. And those two things should multiply back to what you started with, and that's why I want you to think of it. So if I look at the next one, my greatest common factor, I'm going to first look at my coefficients. And the largest factor that goes into both 8 and 4 is 4. All right, my factors of 8 are 1 and 8 and 2 and 4. Those are all the factors. And my factors of 4 are 1 and 4 and 2 and 2. The biggest one they have in common, they both have 2 in common, but the biggest one they have in common is 4. So I'm going to factor out a 4. They both do have an x variable, so I'm going to factor out an x. The one I'm going to use is the one with the smallest exponent, so that would be squared. Now, to figure out what goes inside the parentheses, what do I multiply times 4x squared to get 8x to the third? Well, what times 4 gives me 8? That would be 2. And what times x squared gives me x to the third? Remember, when we multiply variables, we add the exponents. So I had 2, I need one more to make 3. Then over here, what times 4 gives me 4? Well, that would be 1. And what times x squared gives me x squared? That would be 1, because I already have all the x's I need. So that's just going to be 2x plus 1. Do not leave off this 1. Okay, if this happens to be the exact same term, you're multiplying it times 1 to get that. If you leave that off and you just say 4x squared times 2x to the first, that gives me 8x to the third, but it doesn't give me what I started with. You need that 1 to multiply back to what you started with. Okay, so that's greatest common factor. The next kind of factoring that we learned is factoring by grouping. And you're going to use this when there are 4 terms in the polynomial. And what you do is you group it into two sets of two. So I'm going to group these two together, and I'm going to group these two together. And you just look at that group. And now what we did before with the greatest common factor, you're going to do that for each group. So I'm going to look at 4 and 6. What number goes into both? What's the biggest number that goes into both 4 and 6 evenly? 2 goes into both of those. They both have an x, so I can take an x out, and I'm going to use the one with the smallest exponent, which would be x squared. To figure out what goes in the parentheses of that factored polynomial, I'm going to say what times 2 gives me 4. That's 2. I have 2 x's. I need 3, so I need one more down here. Because x squared times x to the first will give me x to the third. This is a plus. What times 2 gives me plus 6? That would be a plus 3. And I have x squared. That's all I need, so I don't need any more x's there. So that's factored the first one. And then you leave that. When we look at the next group, one thing I want you to always remember, on the second group, whatever this sign is on the outside of the first term, that's what you're going to be factoring out. So if that's a plus, I'm factoring out a plus. If that's a negative, I'm factoring out a negative. You look at the coefficients. What goes into both 2 and 3 evenly? There's not, so you're going to use a 1. I don't have an x on the 3, so I can't factor an x out. So all I'm factoring out is a negative 1. Sometimes it'll be a positive 1. But if you don't have any common factors of the coefficients and you don't have the variable in all terms, you might only be factoring out a 1 or a negative 1. In this case, it's a negative because the number in front of that first term was negative. So if I factor out a negative 1, then follow along with me. What times negative 1 gives me negative 2x? Well, that would be a positive 2x, right? Because negative 2 times 1 is negative 2, and then I need the x. What times negative 1 gives me negative 3? Well, that would be a positive 3. Negative 1 times positive 3 is a negative 3. All right, so be really careful when we're factoring out the negatives to take your time with that. Now, notice that I've got 2x plus 3 here and 2x plus 3 here. I'm going to take that and factor it out and put it out front. So I've got 2x plus 3. And if I take that out of both of those, what's left here, if I take that out, I'm left with 2x squared here. And if I take it out of this one, I have a minus 1 here, and that's what goes in your second parentheses. And that's the factored version of that 4-term polynomial. And let me just box that so you know this is, and so that's your answer. All right. So first you group it into two groups, factor each of those groups, and then this term that's in common, factor that out, and whatever's left goes in the second parentheses. So let's try that again. If we've got two groups, my two groups are going to be this group and this group. You just look at one group at a time at first. 9 and 6, the largest factor of both 9 and 6 is 3. I do have x's in both of those, so I'm going to take out an x. The exponent on that variable is going to be the smallest of these two, which is 2. Then, what times 3 gives me 9? 3. What times x squared gives me x to the third? I need one more. What times 3 gives me positive 6? That would be a plus 2. I have x squared. That's all I need. I don't need any more x's. Okay, so that's that first grouping factored. I'm going to factor the second grouping. This is a plus, so that means I'm factoring out a plus. 15 and 10, the largest number that goes into both of those evenly is 5. I don't have a variable on the 10, so I cannot factor out a variable. 5 times 3 gives me 15, but I need an x, so 5 times 3x gives me 15x. And then 5 times 2 will multiply back up to be the 10. The term they have in common, this parentheses, I'm going to factor out in front. So I have 3x plus 2. And then what I have left behind it, after I factor that out, I'm left with 3x squared and plus 5. And that's factoring by grouping. Okay, the next factor we have is when we have trinomials. Trinomials means we have 3 terms with a leading coefficient of 1. So that means my x squared term doesn't have a coefficient, it's just 1. All right, and if there's a quick way we can do this, if and only if I don't have a number other than 1 in front of my leading coefficient, in front of the x squared term. And what we want to do is take factor, we want to factor our C term. So on this, my A term is 1, my B term is 6, and my C term is 8. So if I factor 8, positive 8, the factors of positive 8 are 1 and 8, 2 and 4, negative 1 and negative 8, and negative 2 and negative 4. And I need numbers that will multiply to be 8 and then add to the B term. Okay, my B term is 6. So which of these sets, 1 plus 8 is not 6, 2 and 4 is 6, negative 1 and negative 8 would be negative 9, so that doesn't work, and negative 2 and negative 4 would be negative 6, so that doesn't work. So it's positive 2 and positive 4. These two numbers are what goes inside the parentheses. So you have x plus 2 and x plus 4. And that's a shortcut that you can do to avoid splitting the middle, which we'll do in a minute. But you can only do that if your leading term is 1. Okay, all you've got to do is factor the C term and find two numbers that multiply to be your C term and add to be your B term. So let's do this one. This has a coefficient of 1. I'm going to factor 18. And then I need factors that add to be 18 or multiply to be 18 and add to be negative 9. So these are going to be negative factors. I have negative 1. And the reason we know that they're negative is if this is positive, that means I either multiplied two positives together or two negatives together. Since I've got to come up with a negative number, I'm going to do my negative factors. I've got negative 1 and negative 18. I've got negative 2 and negative 9. I have negative 3 and negative 6. 4 doesn't go into it, 5 doesn't go into it, and now I'm back at 6. And then I look at these. This is my C term. My B term is negative 9. And these two numbers add up to my B term of negative 9. So those are the numbers that are going to go in the parentheses. So I have x minus 3, x minus 6. Remember, you have to split the middle if you have a number in front of your leading coefficient. If you don't, then you can do it the fast way, which is this way. Okay, again, leading coefficient is 1, so I can use this system again. My C term this time is a negative 14. In order to have two numbers multiplied to be a negative, that means one's going to be negative and one's going to be positive. My B term also happens to be negative. It's a negative 5. So a positive and a negative that would add multiply to be 14 would be a positive 1 and a negative 14, or a negative 1 and positive 14. I could have a positive 2 and a negative 7, or a negative 2 and a positive 7. And then I want to look at which ones add to be negative 5. 1 and negative 14 is negative 13. Negative 1 and 14 is positive 13. This one, 2 and negative 7, those add to be negative 5, so those would be the two numbers I use. So I have x plus 2 and x minus 7. And so we can go straight to those answers when my leading coefficient is 1. When your leading coefficient is not 1, when I have a number other than 1 in front of my 2, or excuse me, in front of my x squared, that's when we've got to split the middle. Okay, and the way that we split the middle is I multiply a times c, and I use a little x. A times c goes in the top of my x. So in this case, I have 2 times 8, positive 2 times 8, which is a positive 16. And I put my B term down below here, my B term here. So I have my A is 2, my B is negative 17, my C is 8, so my B is negative 17, I put that here. And we need to find factors of A times C that add to be your B term. So I need factors of 16 that add to be negative 17. It's a positive 16, so that means they're either going to be both positive or both negative. Whoops. Both positive or both negative. They're going to both be negative because they have to add to a negative. So this is going to be a negative 1 and a negative 16. Those multiply to be positive 16 and add to be negative 17. These numbers are going to be what I split my middle term into. So the first term is going to stay the same. The last term is going to stay the same. But this middle term is going to be a minus 1x and a minus 16x. I use these numbers to split that term into two. And the reason we do that is so that then we have 4 terms so we can factor by grouping. Okay, we split the middle into 2 terms so that we can factor by grouping. You have to split the middle if this first coefficient is anything other than 1. Okay, so I'm going to group these 2 together first. 2 and 1, there's nothing that goes into both of those, so I'm going to factor a 1 out of my coefficients. I do have an x in both terms, so I'm going to take that out. The smallest exponent is x to the first, so that's what I'm taking out. And you can put the 1 in front of it, or you can just leave it as x, that's fine. What times x gives me 2x squared? Well, 1 times 2 gives me 2. I have x to the first, but I need another one, so this is going to be 2x. And then what times 1x will give me negative 1x? That would be a minus 1. Minus 1 times 1x would give me negative 1x. Then we go to our second grouping. And remember, when we're factoring by grouping, if this sign in front of that second group is negative, that means I'm factoring out a negative from this group. So I just go ahead and put the minus sign there so I don't forget that. 16 and 8, what's the biggest number that is a factor of both 16 and 8? And 8 would go into both of those evenly. There's no x on the 8, so I can't factor an x out. What times negative 8 gives me negative 16? That would be a positive 2x. What times negative 8 gives me positive 8? That would be a negative 1. Now I'm going to take this term, notice they're exactly the same, and I'm going to factor it out and pull it out in front. So when I pull that, I have 2x minus 1. And when I pull that out, I have left the x and the minus 8, and that's what goes in the second parentheses. And you're finished. Okay, we have another split the middle because my first term is not a 1. So I have a is 6, b is negative 5, and c is negative 6. So if I take my a times my c, a is 6 and c is negative 6, so that's a negative 36. My b term I put here, that's a negative 5. I need 2 numbers that multiply to be negative 36 and add to be negative 5. Since this is a negative 36, I know one of them is negative and one's positive. And if you can't think off the top of your head what those factors are, just start listing them. So I have negative 1, well, and since this is negative, that means the larger factor has to be negative. So 1 and negative 36. 2 goes into 36 8 times, so 2 and negative 18. 3 goes in there 12 times, so 3 and negative 12. 4 goes in there 9 times, so 4 and negative 9. And then we'd have 6 and negative 6. So where one's positive and one's negative, to make it to multiply to be the negative 36, and then the bigger one's negative so that they add to be a negative number. And the only one that works is 4 and negative 9. So that's what I'm going to put here. For these factors, I have 4 and negative 9. And that's what I'm going to split my middle into. Now I will have people say, does it matter if the 4 is first or the negative 9 is first? It won't matter. Your factoring by grouping is going to look a little bit different, but you'll get to the exact same answer at the end. So the 6x squared stays the same. The minus 6 stays the same. I'm splitting my middle term into positive 4x and negative 9x. So plus 4x and minus 9x. Now I'm going to factor by grouping. I'm going to factor these two together. The largest number that goes into both 6 and 4 is 2. They do both have x's, so I can pull an x out, and it'll be x to the first because that's my smallest exponent. 2 times 3 gives me 6. X times x will give me x squared. 2 times positive 2 will give me positive 4. I already have the x, so I don't need any more, and that's the end of that. On this one, for my next group, that first term is negative. That means I'm factoring out a negative. 9 and 6, the largest number that goes into both 9 and 6 is 3. 6 doesn't have an x, so I can't take an x out. Negative 3 times positive 3 gives me negative 9, and I still need the x. Negative 3 times a positive 2, negative 3 times positive 2 gives me a negative 6. And that's the end of that. If you've done it right, you'll notice these should match. If those don't match, you need to go back and see what you factored out wrong. And usually it has to do with factoring out the negative correctly. Okay, so that's the one I'm going to write down first, 3x plus 2. And when I take that out, what I've left is 2x and minus 3. The 2x and the minus 3 go in the second parentheses. All right, so that's factoring by splitting the middle as a review of that. Okay, the next special case we have is a difference of squares. And the difference of squares, this is a perfect square. And this is a perfect square. Both of those terms have to be perfect squares. And what that means is there is one thing that you can multiply by itself to get that number. So we look at the roots. For x squared, the root of that is x. X times x is what gives me x squared. For 9, the square root of 9 is 3, because 3 times 3 gives me 9. Those are your roots. To write the factor, you do 2 parentheses. In both of these parentheses, you write the roots. Okay? So I put x and 3 and x and 3. All right, so you do 2 parentheses. In both parentheses, you're going to have the same terms. It's going to be the perfect squares. One's going to be plus and one's going to be minus. So that's a difference of squares. And I'm not going to do this on all of them, but I'll show you on this one. The reason it works, so this is your answer. But if I was to FOIL that back, what happens is I have x times x is x squared, x times minus 3 is minus 3x, 3 times x is 3x, and 3 times negative 3 is minus 9. And when I combine like terms here, the positive and the negative cancel, and I end up with x squared minus 9. So it'll multiply back to be that term. But the shortcut is that you have 2 parentheses, the roots go in both parentheses, one of them has a plus and one has a minus. So this would be your answer. But this just kind of shows you that if you multiply it back, you get what you started with. Okay, so let's do another one. My 25 is a perfect square, and what I'm going to do is I'm going to write the roots underneath. What times itself gives you 25? Well, that would be 5. 5 times 5 is 25. X times x gives me x squared, so that's the root of that. And 4 times 4 is 16. That's the square root of 16. So these are my roots. So I'm going to take 2 parentheses. Those roots are going in both parentheses. One's plus and one's minus, and that's your answer. Pretty straightforward. Okay, that's only if those are perfect squares. The next one, and this is the one that people tended to struggle with a lot, I know in Algebra 2, is the sum or difference of cubes. I'm going to write, for both the sum and the difference, I'm going to write the format, and then I'm going to talk through how I remember it and how I think of it. If I've got a cubed plus b cubed, and you might want to have a note card with like 1 through, say, 10 or 15, and then list what the square is of those and then what the cube is of those, so you start to remember recognizing what perfect cubes and perfect squares look like. You can talk to your teacher about how to get that set up, but you can just write them down next to each other in a note card to have it to refer to. You won't be able to use it on a test or quiz, but at least while you're reviewing and working through homework, that might help you recognize things a little bit quicker. Okay, so a squared plus b, or a cubed plus b cubed is going to be a plus b times a squared minus 2ab plus b squared. And then if it's subtraction, it's sort of the same thing, but a couple of signs switch. This becomes a minus b times a squared plus 2ab plus b squared. And the signs, the way we remember where the signs go is SOAP. Same, opposite, always positive. So the first one, whatever this is, the first one's going to be the same. The next one's the opposite of that. The last one's always positive. This is a minus, so this is same, opposite, always positive. And just like we did with difference of squares, what I need to do is write what the roots are underneath first, And these aren't square roots, these are cube roots because these are perfect cubes. So that's something that you take it, times itself 3 times will give you that number. The cube root of x to the third is x. The cube root of 27, 3 times 3 times 3 is 27. That's a cube root of 27. So those are my roots. So then when I know when I have a sum or difference of squares, I'm going to have a binomial and a trinomial. And I put the parentheses in first. And the binomial gets the roots. Just like it does in difference of squares, the roots go in the binomial. What's different about the trinomial, for the trinomial, whatever this first root is, you square it. Whatever this last root, and that's your first term. Whatever this last root is, you square it, and that's your last term. Notice I'm not putting any signs in. The signs are the last thing you should put in. The middle term, you multiply these together and double it. So 3 times x is 3x. If I double it, it's 6x. Now, I use SOAP. Whatever this one is, this one's the same, this one's the opposite, always positive. And that's your answer. So let's try it again. We take our roots. Cube root of 8 is 2. Cube root of x cubed is x. What can I multiply times itself 3 times, or 3 times to get 1? Well, 1 times 1 times 1 is 1. Oops, I don't want that there. I just want the roots. So my roots, the cube root of 8x cubed is 2x. The cube root of 1 is 1. Just like the square root of 1 is 1. Okay, so you're going to have a binomial and a trinomial. The roots go in the binomial. For the trinomial, your first term, you're going to square it. Now make sure you square the coefficient and the variable. 2 squared is 4. 2 times 2 is 4. X times x is x squared. For the last one, you're going to square your second term. 1 times 1 is 1. For your middle term, you're going to multiply these together. 2x times 1 is 2x, and double it. 4x. I don't put any signs in until the very end. And when I put in the signs, I use SOAP, same, opposite, always positive. This is positive, so that's going to be the same. The first one's going to be the same. This is going to be the opposite of that. Last one's always positive, and that's your answer. Okay, so your homework's on there on the notes. And then also the test review on that page, it's part of your homework for tonight.